know the population standard deviation. You're going to state the claim. The one with the equal sign is which one? What do you think, Marissa? The one with the equal sign is which one? HO. Good. And graph, we go by which one? HA. Good. Okay, so we're going to state those. We're going to find our level of significance. We're going to find our test statistic. This is what you're testing. Your z-score, you test it against your sample. We're going to find the area, and area is always to what side? To the left. Good. We're going to find your p-val, which is your probability value, your area under the curve, and then we're going to make a decision. Your decision is the small little table. You're going to test your p-val right now against your level of significance and either reject HO or fail to reject HO. Then we're going to use the big chart and we're going to interpret your decision. Okay. So, here we go. A study says that the mean time to recoup the cost of bariatric surgery is 3 years. You randomly select 25 bariatric patients and you find their mean to recoup the cost of their surgery to 3.3 years. You assume your population standard deviation is 0.5 and your population is normally distributed. Is there enough evidence to doubt the study's claim? Now look how they wrote this. To doubt the study's claim. What is the study's claim? So how would I write that? The mean is 3. Good. Is 3 years. Is it the HO or the HA? HO. It has the equal sign. And then the HA would be not equal. This is where the tail comes from, the HA. Okay? Now, if we're doubting the study's claim, usually it says, do you reject, do you support? Sometimes they throw different words at us. Okay, we randomly pulled out our sample. We have 25, God bless you, in our sample. And we found that their sample mean is 3.3 years. And we found that a previous population standard deviation is 0.5 years. Now, why did they tell us that? Why do we have to look for that the population is normally distributed? No? Why does it have to be told to us?
Because it's less than 30.
Good, because it's less than 30. N is less than 30. If N is greater than or equal to 30, then we don't have to, it automatically is normally distributed. Because it's less, that's a test that we do. We just do it in our heads, kind of. And if it fails, we wouldn't be able to do the problem at all. So we've got all our information. What type test is this? What tail? 2 tails. 2 equal tails. There's a negative Z. There's a positive Z. Okay? So we're going to test. We're going to find the level of, so we know our level of significance here. We're going to find your area under that curve, and we're going to compare it to your level of significance. To do that, we use your z-score. Remember, it's a sample, so you have to divide your standard deviation by the square root of n. So your x bar is 3.3 minus 3 over your standard deviation divided by the square root of 25. So let's find your z-score. Everybody find the z-score with me. I don't want to hear later, I can't put it in the calculator. It didn't work in the calculator. So would we get, which side should it be on, the right side or the left side? Which side should it be on? What's the top going to come out, positive or negative? Positive, so it should be on the right side, right? So, what's my z-score? Three. Good. 3. So this is a positive 3. This is a negative 3. I need to find the area. So I have two equal tails. Find me the area of one of those tails. Find me the area of one tail. Yeah. Area should be 4 decimals. Hmm? 0.0013. Did everybody get 0.0013? Okay, now what? It's 2 tails. Now what do I do? Won't these both be the same? Multiply it by 2. So I'm going to take my area and I'm going to multiply it by 2 because I have 2 tails. Now, this is my p-val. Now I'm going to test my p-val against my level of significance. Fill it with zeros. Drop the decimal. Is 26 greater than or less than 100? Less than. So this is the less than or equal to. So I look at my chart and I say, if p-val is less than or equal to the level of significance, what's my decision? Reject HO. Don't say reject because you have an HO, you have a claim, you have an HA. Now, this is my decision. My interpretation says this. I come over here. I say my claim is my HO. I rejected HO. I have to start it out like this. There is enough evidence at a level of significance of 0.01 to reject the claim that the recoup cost of bariatric surgery is 3 years. You ready to get that whole interpretation? Okay, so I'm using this as my, kind of like a skeleton to help me fill this in. I have to use these specific words in here. Okay? If it's a left-hand test, you look up your area, it's your area to the left. If it's a right-tail test, if you look up that positive z-score, you have to subtract your area from 1, or you can look up the negative z-score of it, just to use for the p-val. So I want to see claim, HOHA, sketch. Notice I don't put any other numbers out there. That's all we basically need for a sketch. Formula, decision, interpretation, which I didn't write. If you use your calculator, great calculator, step. It's in tests, it's in z-score. Your population standard, your population mean is from your claim. Your standard deviation, they gave us 0.5. Your x-bar, this is from your sample, 3.3. How many in our study? 25. Follow the tail on this, of the HA. If the HA is less than, you use the middle. Greater than, if it's not equal, I hit the not equal one. I calculate. There's my p-val. It's a little bit more exact than ours, so 0.0027. It gives me my z-score back, in case you want your z-score. It always gives you back usually the positive, unless it's a left-tail test. So on an equal, it'll give you back the positive. If you like to use the calculator, you get to bypass this whole piece in here. It does your z-score formula, and it gives you your p-val. Don't take your p-val and multiply it by 2.
My question is, where do you get this 0.0013?
From table 4. So go to 3.0, you'll see 3.0, and you find the 00 up here, and this should say 0013. No, this should say a big number, 999 something, and you got to subtract it. Go to the negative one, and that'll say 0013. You can look up the negative because your tail, well in this case too, you have a double tail anyway. But even if your tail is a right tail test, you can look up the negative one. It's the same size.
Use the low significance, usually that's all.
It's either going to be a 0.01, 0.05, or 0.10. So, because if you think about it, it's the opposite of your level of confidence. Like a 95 was the most common, so that'd be a 0.05. A 99, that'd be a 0.01. And a 90 would be a 0.10. It's kind of like the opposite. Okay, so now, I'm going to give you some to do. A couple at a time to try. So you're going to work these out now. And then we're going to go over them. This period. So if you kindly turn to page 374. 373, 374, that's fine. 370, yeah, 370. Let's have you do on 374. Let's put this somewhere. Do 17 and 18. You're going to use your calculator to make a decision. And then
There's more, it's quite hot in here.
okay, hang on. Okay. Then I want you to do number 27,
Focus on that.
30, and 31. 31, I only want you to do a p-value. Ignore the reject region part. It'll say do a reject region, just do a p-val. Just ignore the reject region part. Can you slide your window open a little bit? Okay, these were nice, they were calculator steps. So when you do this, you're a z-test. Don't forget the U is from a population mean. That is what comes from your statement, whatever your claim is. They make a claim about a population. They test from the sample. And we also had to know that the population standard deviation was. So we plug it all in, and we can tell that they're doing a two-tailed test. That automatically will double your tails in this. You don't have to do that at all. Notice it gives you a z-score. So it repeats what your claim is, that it's not equal to 60, because what it did is it took this 60 and put it right in here. It said U is not equal to 60. It used the not equal. See how it replaced this right here? It took this and replaced this. So this reads U is not equal to 60, which is your claim. It calculates and doubles the p-val. It wanted you to test this at a level of significance of 0.05. So we test our p-val against 0.05, and remember, fill it with equal amount of zeros. So 63 is greater. We follow our chart, and we say reject HO. The second one, we have a right tail test. This is as our HO. So it's saying that the mean is greater than 742. This is your claim. Okay. And, or it's your HA rather, it's your HA. It follows through. It took your p-value, and it's a one-tail test. It already does it for you. Test against the level of significance of 0.01. Again, fill it in. It's less than or equal to, so you say reject H0. I'm not a stickler if you don't put the equal to sign. If it should perhaps be equal to, then you need to. But if you don't, that I'm not a stickler about. Okay. So 27 gave us a claim, which happened to be our oops, mine's backwards here. Here's mine backwards. This is your HO. This is your HA. Okay. HO and HA. Your claim they gave us, we don't know what the scenario is, but they gave us the sample information, they gave us the standard deviation. So we find it all, we have a two-tailed test. We have to multiply the area by 2. When you get your z-score, don't forget, they're the same on both sides. It's symmetric. So look up just the negative and multiply it by 2. And then compare it to the level of significance, which was 0.05. Fill it with zeros, and it's less than or equal to, so reject HO. You're always testing the null statement. We're assuming that it should be true, and we're testing it. From there, we follow your chart. Your claim is your HO. You reject HO. You have to say, there is not enough evidence at a level of significance of 0.05 to reject the claim, and then all they gave us was this. My p-value was 0.0166 times 2.
When the calculator is 0.04.
Am I off?
Yeah.
I might have had, because I noticed that this was backwards, I might have had an old one in here and
But
not...
you can still get the same result either way.
Right, but I just need to test this. Is everything else on here right? Is it the same as yours?
Yeah, like
No,
the
that
z-score is
is
negative 2.03. That's right.
That's right?
Yeah.
Okay. Let me just look this one up. You know what happened? My book changes, and sometimes I get an error in the teacher book, so I think because I have 2 different colors, I might have changed it to match your book, but I didn't get the whole thing.
I mean, it's still the same thing.
Yeah, but I got to get you the right z-score. I don't know why this is doing this. 0.02. You got 0.0212? Is this what you guys got? And then you multiplied it by 2? So this should be in here. This is wrong. And it takes the same value in here. Same decision. Sometimes when they do the teacher one, it's a they change the problem on it.
How could you tell when it's two-tailed test?
Because you look at your HA, your HA says not equal is a two-tailed test. Okay, hang on. We just got 2 more to go through here. Or we can actually go through one of these tomorrow morning. That might help. Okay, here's your claim. Is your HO. It has the equal sign. Your HA, no equal sign. You have a right tail test. You follow your HA. Look how high this z-score is. That z-score is well off that chart. So essentially the area to the right of it is essentially 0. So you're testing a 0 against any number, it's going to be less than. Again, you reject your HO. You have to follow your chart. There's enough evidence. Guys, let me just finish these last ones. That the mean, to reject the claim, that the mean is less than 22,500. And the last one, they gave you your sample first before they gave you the claim. But they gave you a nice hint here. Do you have enough evidence to support the student's claim? So, find the student's claim up front. And make the claim, make the HA. Where's the student? We can go over this one tomorrow, right before the test. So the university did the sample. A student claimed, this is the claim right here. It came second. Just be careful. Again, you're having a right tail test. if you look this up, you get this huge number. Don't forget to subtract it from 1. Or what's the other way I can look that up? The negative. It's equal over here, negative 2.83. Again, you're rejecting HO, but you've got to use the same word from that chart. Everybody okay with this?